Osteology and orthopedics are the medical branches concerned with the study and treatment of bones. They differ slightly in their focus. Osteology is focused on bone formation, metabolism, and diseases of bone. Orthopedics is concerned with the entire musculoskeletal system and its diseases to include joints, tendons, ligaments, and nerves. Osteo is the morpheme for bone, logi the suffix meaning study of. The origin of orthopedics is a little more interesting. Ortho is from the Greek meaning right or correct, and pedic is derived from the Greek for children. It is a term that was originated by a mid-18th century French physician to describe the treatment of children with deformed limbs. Major functions of bones. Bones provide structure and bear weight for the soft tissues of the body. They provide surfaces on which muscles can act. They protect vital organs such as the heart, lungs, and brain. They also act as reservoirs for calcium and phosphorus in our body and provide these minerals as necessary for cellular metabolism. And they produce blood cells in their marrow and release these into the blood. There are two types of bone in the body, trabecular bone and cortical bone. The dense cortical bone is what bears the weight of the body. The main function of trabecular bone is to redistribute force from the articular surfaces to the cortical bone. It also plays the largest part in mineral contributions of calcium to the blood for metabolism and absorption of calcium from the blood. The shapes of bones. Short bones. These are bones as long as they are wide. For example, the cuboidal bones of the foot. Long bones. These are bones that are longer than they are wide. For example, the femur. Flat bones. These bones are flat and not thick. Example, the sternum of the chest. Sesamoid bones. For example, the patella. A sesamoid bone forms in a tendon as it passes over an angular joint. The patella is the largest sesamoid bone in the body. Irregular bones, like the vertebra. These irregular bones do not fit in any of the above groups due to varying and complex shape and structure. Anatomy of a long bone includes the following. Articular cartilage is found on the terminal portion of a bone. This provides a surface for interaction with another bone in a joint. Epiphysis is the end of a bone. It includes the articular surface on the terminal end and the epiphyseal plate on the other. In the diagram, this is noted as the epiphyseal line. In infancy and early childhood, the epiphysis is separate from the rest of the bone, but it eventually fuses with the bone at the epiphyseal plate or line. Metaphysis is located between the epiphysis and the diaphysis. The metaphysis contains the bone growth plate. This is where new bone originates to add length as a child grows. Diaphysis or bone shaft is the long portion of a bone. Within the bone shaft is the medullary cavity, which is where bone marrow is found. Bone marrow is an important source for both red and white blood cells. In the body, new bone is constantly being formed and existing bone is resorbed in a dynamic process which allows bone to respond to the ever-changing stresses on the skeleton. Important cell types in this process are osteoclasts, osteoblasts, and osteocytes. Osteoblasts are cuboidal mononuclear cells that form on bone's outer surface in the periosteum. They are responsible for making new bone. They represent only 4 to 6% of bone cells, but they produce most of the bone material. After forming bone, they mature into osteocytes and maintain bone. Osteoclasts originate in bone marrow. They are multinucleate cells with finger-like projections called microvilli, which resorb bone on its inner surface. According to the National Institutes of Health, there are 206 to 213 bones in the adult human. Babies tend to have more bones, but some of these fuse as they grow. The exact number of bones can vary slightly because some people have extra ribs, vertebrae, and digits. As a medical specialist, you will need to know all the names for these bones. That will take time, but this is not as difficult as it may sound, as the naming of bones is very systematic. For example, many bones are bilateral. That is, the same bone is found on each side of the body. These bones have the same name and are differentiated simply by adding the words right or left. Other bones, like the ribs and phalanges, have the same basic structure and are differentiated by right, left, and a number in sequence. For now, let's just take a whirlwind tour of the skeleton. Examine the following labeled diagrams. There is a lot to these diagrams, so I will give each slide a setting of about 30 seconds. If you need more time, and who wouldn't, I will create a button for downloading these images on the HIP, Health Information Project website. If you are using PowerPoint, you can override the time setting to go back and forth. If you are watching the video version, you can try pausing the video. The next presentation in this module will be on bone disease. The preceding 6 anatomical diagrams will be available for downloading in this module on the HIP website.